First, I'd like to state my disappointment. I've been working on this white paper trying to explain a bunch of things, and I thought, okay, I can just throw this into Claude or something like that and turn it into a nice PowerPoint, and I was bitterly disappointed. So that there's some additional work to be done there, and so I'm just going to be reading off of them. So what I've been working on, well, first off, I think realistically there are probably three things that Congress can do right now that will move the needle in important ways. The first one is a secure digital ID for all Americans who want one, because the problem with impersonation is just, it's a huge problem for cybersecurity, huge problem for fraud, just all over the place. The EU is doing pretty well on this. I think by the end of next year, every EU citizen will have the ability to prove they are who they say they are online, and the United States should not fall behind on that. And the politics are improving on that in large part because of the hundreds of billions of dollars of identity fraud that happened during COVID. So that's one thing I've been working on for 5 years, and I think 50% chance that we'll get that done this session of Congress. Then that will be, a lot of the abuses of AI will be improved if we can get that to happen in the United States. The second one is this business of smuggling chips to China. I believe that compute is going to remain very, very important. If everyone had AGI software today, then the question is how many copies of that can you deploy, and that's limited by compute. And so that's going to be, when the singularity hits, that's what's really going to matter. And we're very fortunate that all of the choke points in producing these high-end AI chips happen to be in the free world, which is probably not an accident. But really, then I believe it is a shared responsibility for the 6 or 8 countries who own the choke points. You can just run down the list. It's the Dutch, it's the French, it's the Germans. As a physicist, I'm just so blown away at what these giant lithography machines do, the ASML machines that are really the enabling technology, as well as a lot of the device physics that comes out of Korea. The resists, photoresist and everything from Japan. And so all of these countries, the free democracies of the world, have a shared responsibility to make sure that this technology doesn't get into the wrong hands, by which I mean basically China, Russia, Iran. And so that is why I've been so involved in trying to move the needle on hardware enforced mechanisms. Now, first to determine whether or not a chip has been smuggled, and secondly, if it is determined to have been smuggled, to make sure that there's some sort of licensing mechanism in place where the chip will cease operating if it has been smuggled. And so, there's a lot of what I'm going to be talking about actually is the technical aspects of that. The political aspects of that is that we have just introduced in a bipartisan, bicameral manner, which means the House and the Senate, Democrats and Republicans, have introduced an identical piece of legislation to mandate that high-end AI chips, GPUs, I'll be calling them, that these contain the necessary circuitry to respond to prove they are where they say they are, and I'll be talking about that in more detail. And secondly, it has a study but not a mandate for additional mechanisms, by which I mean hardware enforced, time-limited licensing. This would mean that the owners, the operators of these GPUs would from time to time have to go back and connect with some entity controlled by the trusted democracies of the world to say if they still have permission to run their chips. And this will certainly be necessary when we start deploying these into countries with intermediate levels of trust, I will call them. And this is you can make the argument if it's Google in the United States, you can kind of trust that they'll keep things under control. But then you get companies you might trust who are setting up in Malaysia. Then maybe we should look a little more carefully at exactly what they're doing. And the first step is, are these deployed where they claim to be? Because I guess there are now famous instances where a data center in, I think it was Singapore, was set up, inspected by NVIDIA, said yep, and then next week, the week after that, they came back and the data center was empty. And unless you have a way to first detect that that's happening, and secondly, take action that causes them to stop working. Okay, so how does this work? And there may have been some discussion of this earlier, but the basic mechanism for a GPU to prove that it's in a location is that you need what I call a trusted sentinel module. A trusted electronic sentinel module. This is a hunk of electronics that you trust and you know where it is, you believe you know where it is, and it can communicate very rapidly with GPUs in its vicinity. In particular, it can go and query a GPU and send a cryptographic ping to it, and then measure, and the GPU will very quickly sign it with its secret number that proves it is who it says it is, and return that rapidly. And if you can do that, for example, in under 10 microseconds, then you have an assurance based on the speed of light that GPU is no more than 1 mile from the trusted sentry module. And so that's the basic mechanism. What you're asking of the GPU is simply the ability to have that secret number embedded in it, which they all do. The hardware root of trust is the buzzword that goes with it. And then it has to be able to rapidly sign a cryptographic challenge and return it. And all of these high-end GPUs or the data centers have incredibly fast data networks inside of them. So once you're connected to the data network, you can very rapidly, in sort of sub-microsecond times, get the information that out of the GPU that you need to prove that you've done it. So then all right, for all of these things, you're immediately trying to anticipate the objections to this, and so the first one, this is going to be a pain in the ass and it's going to be expensive. And so just in terms of just saying what is the cheapest, simplest, plausible way of doing it, I believe you could do a good job on this with an iPhone. A managed iPhone can't be jailbroken, connected to a fiber optic, connected to the network spine in the data center. And so this would allow I guess it would probably surprise no one in this room that if you're operating an iPhone, that many people have satellites up there that know pretty exactly where that iPhone is. You see this SOS that appears when you're like on an airplane and something like that. Yeah, I wonder how accurate that is. The advertised accuracy of that, I think, is 100 meters. But it would not surprise you to find out that, particularly if you have cooperating software in your cell phone, you can know quite exactly where that cell phone is located. And then if it is then, once you know that cell phone is there, you verify that it has not been jailbroken, which can be done. There's been a tremendous amount of work over the last couple of decades making it pretty much impossible to jailbreak modern iPhones, for example. So you have a pretty secure compute platform there. You know where it is because the communications with the satellite, and then all it has to do is be able to do the roll call. If it's located on a data center with 100,000 GPUs, it has to be able to, one at a time, ping the GPUs and say, do a roll call effectively. And then the GPUs will one at a time return the cryptographic challenge, and the iPhone will know that yes, that is the GPU that is supposed to be here, and yes, it returned it less than, say 10 microseconds, so it's within a mile of where I am. And that tells you the chip hasn't been smuggled. And so one of the things in the legislation that we have is a mandate for the manufacturers and the distributors of these to maintain a list of where all of their GPUs are actually located, and a database on there, and a mandate to report if all of a sudden the location measurement indicates that it's not where it should be. All right, that doesn't actually stop you from stealing the chips, and that's you could still have the scenario where the whole data center disappears, and so that's the second element of this, and it is hardware enforced time limited licensing. What this means is that every so often the chips, when they, as part of the boot sequence, for example, they will look and say, do I have a currently valid license to operate? That means they have to get their hands on a source of timing that they trust, which can either be out on the internet with a trusted source of time on the internet, or a trusted timer inside the GPU module. It turns out that at least the NVIDIA GPU modules have what they call a TPM, a trusted platform module, that contains such a trusted timer. This allows you to have what's called offline licensing, where you could get the license refreshed once every 6 months, and then every time the thing boots, it could look at its trusted timer, see that it has a license that's valid for this 6 months, and then proceed to boot and refuse if the license is not valid. And so that either one of those two, I think, are workable. One of the delicate issues on there that I haven't absolutely resolved in my mind is this requires a mandatory secure boot on these things. This is like having iPhones that can't be jailbroken. And this is if you read the NVIDIA documents, the public ones, they sort of go both ways on whether or not there's reference to a debug mode inside GPUs that appears to bypass this and appears to bypass the secure boot. That can't be allowed for chips that will be exported. It's a design choice they make. In fact, it's probably a firmware choice that they make to make a secure bootstrap sequence that cannot be, you need things called rollback protection and stuff like that in them to make sure that you actually, there are no ways to cheat on this. But it is something that NVIDIA has worked very hard on for what they call their confidential compute, which is something I'm going to return to at the end of the talk. It's something that we have to be really careful of. And so that is, so that second part, as I'd say, is to be studied but not mandated. And that's something I think that is ultimately going to be important. So the two things, the ability to prove you are where you say you are, and the second thing, having mandatory time-limited licenses. They're both independent and both really important. The advantages or the features, because some people think they're advantages, some not, of having mandatory time-limited licensing on these is that if you're ever, most people believe that there's going to be some responsibility to report what the heck you're doing with these large arrays of chips. And so this provides a touch point for enforcement of that. Because if you say, okay, every 6 months you have to come back and make a report on what you're doing, if all of a sudden, Elon Musk just decides he doesn't have to report anymore because he's Elon Musk, and then fine, you have a touch point. Okay, let's talk about it next time you're getting your licenses renewed. All right, and this, I think, is going to be very important. It also elevates the discussion of who gets to issue licenses. Okay, the concept that if you listen to the White House, their concept is, well, the Great Orange one is he's the ultimate decider on who gets to have these and who isn't. All right, that is not okay with the rest of the free world. There may have been a time, there was a famous instance back in 2001 when the United States presented evidence of weapons of mass destruction. You're probably, I don't know how you're old enough to remember that. And I think it was the French ambassador or premier said, oh, don't worry, the President of the United States says it, we don't need any more evidence than that. Well, those times have passed. There is when I talk to the scientists that I know, who have worked in Europe, worked in Asia, worked in the United States, the level of mistrust of the United States government is sort of nothing I would have ever believed. But that is, I think, representative of the public attitude toward this. So we have control of the key technologies among these 6 or 8 countries that really have the choke points for AI. But what we need to do is to have the rest of those 6 countries stand up and say, we need to have a shared responsibility for governance. And the ability to issue licenses actually forces that discussion. Because it is not okay with the rest of the free world if Donald Trump unilaterally gets to decide who gets their licenses to keep operating their GPUs. All right, it's not okay. But fortunately, the key thing is who owns the key that allows you, the cryptographic key that allows you to issue licenses. And there are ways to split that key and reassemble it. So for example, you can say, okay, of these 6 countries, every one of them gets a key and any 4 of them can issue a license. So if you don't trust, it gets you around having a single point of failure, or what's called a Byzantine fault tolerance in computing. But it allows you to not be subject to a single point failure. of governance. If you're worried about some government that you may not trust forever, or a government, say Taiwan, that may not exist if military actions take place against it. You don't want to have that be a single point of failure, but you can get around this by this sort of mechanism. So this is my long game in pushing this, and one of the big reasons that I got involved in this particular angle here, because if we do this right, I think that we actually will start having AI safety conferences that mean something, because the focus of those is what are the conditions to be issued a license to operate your GPUs. And I think this is, I think, well, like I say, that's my end game on this. So let's see, the legislative, I'm happy to talk more about our legislation, but it's, the interesting thing there is my partner in the Senate on that. My partner in the House is the China Select Committee, which is a group of people who've mostly been trying to make their careers by being tough on China. Fine, all right. I actually agree with a lot of what they're doing. But then my partner in the Senate is Tom Cotton. I don't know how much you know, but he and I agree on approximately nothing. I actually had the pleasure of spending a weekend with Tom Cotton on a nuclear submarine underneath the North Polar ice cap, which is one of the coolest things. It turns out that every couple of years, the U.S. and the Brits go underneath the North Polar ice cap and like shoot fake torpedoes at each other. It's just like really cool. And that if you're a member of Congress, one of the reasons you should run for Congress is that you may be able to do that. But then you have to listen to Tom Cotton. For a whole weekend, but this is it's life in the U.S. Congress, I guess. So there are lots of technical issues having to do with secure, this time-limited licensing. But I think it's workable and it's really important. And then. So I guess that's pretty much it. I could go deep into. I've spent more time than I really should have wasted for myself looking through NVIDIA and other manuals to see, okay, is this actually going to work? And I'm happy to answer questions from the hardware geeks here if there's some. But I think that's sort of what I'm working toward, and it's at least the first part of that, getting a consensus that we at least have to know when smuggling has happened, has actually been like pushing on an open door. That everyone is creeped out and doesn't like the idea that AGI is going to be under the control of a country in which 20,000 people a year disappear into an undocumented court system and never to be seen again. And this is not an okay, it's not an okay situation for us to be in, and that we have to take it very seriously. And this is sort of the first important point there.